Okay, so yeah, I asked you guys to look on the graph for these things. So if you don't have your calculator out, you're not doing the right thing. What's it look like? Cosine x minus 1 over, well, as I asked for you, the limit as x approaches 0. What does it look like it's happening? Okay. Right at 0, it's undefined, but what does it look like the limit is approaching? 0. Okay. That's all I wanted you to get out of that. Just like I asked you guys to memorize this one, there were 2 others in that section. You don't need to use these really. I use them for particularly today's proof. So here's one of them that I just wanted you to see and believe. Like looking at it graphically, there it is. Cosine b minus 1 over b as b goes to 0 is 0. And don't panic. I'm not going to require you to know these. Most calculus teachers do not know the expansion of sine a plus b. But do any of you remember it from pre-calc? Yeah, I don't know the little jingle thing, sine, cosine, sine, then. To me, it's all just, oh, what? Okay. Right, well, I teach pre-calc, so I do know it. But it's sine A, cosine B, sine the sines match. My way of memorizing these things, sine is the peace, love, and happiness hippie trig function. It has intertrigonometric relationships with intertrigonometric angles. Sine the sines match because it's peace loving. They're the other expansions, and split up, and sometimes they write them like this. And again, you do not need to know these. I just need you to remember that it existed, and you did learn it before, because I'm going to use it in a second. Okay, because today I'm going to prove to you with limit definition of derivative how to do the derivative of sine and cosine. And we will get to the other trig functions possibly. Why is it this horrible color? So limit definition of derivative, f of x plus h minus f of x all over h. And you don't need to write the proof down, you will not be asked to reproduce it. This is for me to give you inspiration to memorize it. And, well, also to believe that it's true. Okay, sine A plus B. That was sine x, cosine h, sine sides match, and then we trade the angles around. Sine h, cosine x, minus sine x. Any suggestions on some smushing, moving around? Factor out sine x. Well, sine x doesn't come out of everybody, but that's a good idea. factor sine x out, that, okay. So sine x comes out of this first piece, and the very last piece does not come out of this. Ooh, a comment. Some of you do these cute little, like, oh, there's my fraction bar. No, like, make the fraction bar under the whole fraction, whatever you're dealing with. I am gonna split this up into two different things for reasons. Okay, I asked you guys to type in and look at this one as the warm-up. What did that go to? As h goes to 0, what did that function go to? 0. So this goes to 0, so sine times 0 is 0. All right. What about this guy? Sine h over h times cosine. As h goes to 0, where does sine h over h go to? 1, right? That was the one that I asked you guys to memorize like the first day we started calculus. So in all this, cosine. Derivative of sine is cosine. And if we look at it visually, there's a sine curve. I'm trying to graph things. Horizontal tangent, okay. And then it was a positive slope. Looks like the steepest slope was there. And then this guy comes down, horizontal tangent with negative slopes. Does that look like a cosine curve? So visually there's some affirmation. Doing the expansion, yes, it's true. So the derivative of sine, you can just memorize. Derivative of sine is cosine. You do not need to rederive at all. Okay. So we can do this in the calculator. Just show another way to do things. It will grind your calculator down, just a warning. Should we be in degrees or radians for calculus? Or does it not matter? Radians, always radians, okay? So if you are not in radians and you're trying to do this, it will not work. So just showing you calculator tricks. Math, I want to do the derivative of what, well, I want to now know what cosine looks like with respect to x. So there's cosine of x, and I need to say comma x. So that's the variable, and how is the variable changing with respect to x? Teeny tiny. Okay, I'm going to hit the on button, which stops it. Because it's too small, I want to zoom in. And those of you who are like, oh no, I typed the wrong thing, and you want it to stop and it's going super, super slow, just hit the on button again, and that halts the calculator. And I am going to do zoom 7, which is zoom in on trig. And it's still moving kind of slow, but there it is. What does it look like the derivative of cosine is?
Negative sine.
Negative sine. Okay, yes. One more trick. I want to graph cosine just to see it. And do you know what happens if you arrow all the way to the left? This is, if you guys have an 84, it's really easy to change the color and the look. If it's an 83 like this one, if I hit enter once, that line gets thick. It's just a way to say, draw the graph looking different. So if you arrow all the way to the left, so you can see the original function, cosine, and then its derivative is negative sine. Okay? Sadie, was there a question?
Ours like doesn't do like common X, it does like.
Oh, yours is better. I mean, those of you who have the 84, it's got, then you type in the function and does it say,
But it's like a bar next to or like something.
so yeah, it's saying do the derivative with respect to x of the function cosine when the variable equals x. So yours should be sort of nicer. Anyone else have issues with their respective calculator isms? Yeah.
Where's the X comma?
The X button is next to the alpha key, which is usually green or purple. Do you see it?
Yeah.
Some people went through great lengths, like, all right, guys, it's right here. X comma T comma theta comma N.
Yeah.
And, I mean, we're not gonna do this till chapter 10, but, oops. Wrong thing. So the mode, if we're on function, the calculator, that button's gonna type an X. If we're in parametric, it's gonna type a T. If you're in polar, G, the third one, it's gonna give you a theta. And sequence, it'll give you the N for this button. No big deal. Just the letter changes depending on what mode you're in. Anyway, so all of that was to say derivative of cosine is negative sine. So again, limit definition with cosine. Cosine expansion of a plus b is cosine a cosine b. Cosine is the contrary one, so it's going to be opposite signs, and it keeps its enemies close. Cosine stays with cosine. Sin x, sin h. Doing the same thing Amelia suggested. Factor out cosine. This again, because of the proof we did, or not proof, but we looked at it on the graphing calculator. The limit went to 0. This stuff goes away. And this goes to 1, so I get negative sin x using the limit definition. It was easier to just look on the graph, but there you go.
Can we just say like cosine x?
Yes, you do not need to prove these. So use them. You know the two derivatives now, and you know the derivative pattern for quotient, so use them. Quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So try it with this problem. Claire, you're looking at me like, well, that's done. Roman, you're done? You want to put up for us? Okay, just checking. Vitaly's not here, Evan, Matthias, Sebastian. Okay, Jason, what do I do?
Start by taking the bottom, multiplying it by the derivative of because cosine times 2 times cosine x. And then you do that.
Okay, perfect. So, there might not be much to do, but we should do some cleanup. So Franco, multiplying and cleaning up the numerator. What do I get in the numerator?
Cosine squared x minus 2 cosine x. Minus sine squared x. Wait, plus.
And leave the denominator factored. There's one more thing to do. Diane, what do you see?
Then you can do cosine square x and sine square x is 1.
So be thankful, they don't expect you to remember a lot of the trig identities from last year. This one they want you to know. Cosine squared plus sine squared equals 1. Leave the bottom factored. And sometimes, very rarely, but sometimes it just might reduce. So leave it factored so you'll recognize that. And don't waste your time expanding it when they don't want it. Okay? Okay, derivative of sine was derivative of cosine? Negative sine, okay. Tangent. How can I rewrite tangent with sine and cosine only? Sine over cosine? Okay, so I'm gonna do quotient rule. Bottom times the derivative of the top. George, what's the derivative of sine again? Cosine. And so Lourdes minus top times the derivative of the bottom. What's the derivative of cosine? Negative sine. All over the bottom squared. What does the numerator become? 1. It becomes cosine squared plus sine squared. What's another word for 1 over cosine squared? Secant squared. So tangent is secant squared. Okay. Cosecant, I'm gonna rewrite cosecant as 1 over sine. Okay, so I haven't taught you guys chain rule yet, so I need to go old school. I'm gonna do this by quotient rule. Bottom times the derivative of the top. What's the derivative of 1? 2. Oh, that's nice. Minus the top times the derivative of the bottom. Derivative of sine is positive or negative?
Positive.
Okay. Over the bottom squared. That goes away, so I am left with negative cosine over sine times 1 over sine. I'm writing it this way on purpose. negative cotangent x cosecant x. Okay. Secant is 1 over cosine. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That goes away. I have sine over cosine times cosine. Oops, sorry, I'm secant. Some of you might see a pattern, some of you might not. Cotangent is cosine over sine. Okay, bottom derivative of the top minus the top times the derivative of the bottom over the bottom squared. I have negative sine squared and negative cosine squared. I'm going to factor that negative out. Okay, so there's all our trig functions. Make sure you have them written correctly. All right. So, all the cool kids, they want to be sine and cosine. They're the cool trig functions. So they have each other as their derivatives. If you notice, all the ones that begin with C are negative. Contrary, contrite, pick some word that means some negative connotation that begins with C, that's them. Okay, sine and cosine, again, they take each other as their buddies. So tangent is like, hey, I want a friend. He's gotta take a friend from the second tier of friends, so he takes secant. Why secant? Well, I told you guys to remember, if you can only remember one, this one's good. If I divide everybody by cosine squared, secant and tangent, they've been friends before. They've been in connection with stuff before. So tangent, secant squared. Secant, everybody's least favorite trig function, rude. It puts itself in its own derivative and brings a friend. Which friend? That friend. The others, well, and the negative ones, those are just unmentionable and the worst ever. But if I divide everybody by sine squared in this equation, derivative of cosecant, rude, it's negative, it's cranky, puts itself in its own derivative and brings a friend. Which friend? That guy. And cotangent's derivative is negative cosecant squared. They tangent and secant hang out together, sine and cosine hang out together, cotangent and cosecant hang out together. They just do in lots of relationships. And we will do the proofs of the trig inverses after your test. You have a test on Monday. I really need to get those quizzes graded and back to you soon. This test coming up on Monday, I have not given that one ever. Usually you have a 2-day test at the end of chapter 3. So, don't know what's on it yet, sorry. Yeah. Can you guys try this equation, or try this problem? Find the derivative, find the equation of the tangent line to that. You will need a calculator to get numbers. Can someone do the derivative on the board for us to find the tangent line? Naomi? Yay. Just do the derivative.
I'll try.
Okay. Yay. So is this a power rule, quotient rule, product rule, or something different? Product rule, because it's first times second. Yeah, the board, I hear you. Okay. So you did it backwards for me, but that's okay. It's not wrong. It just hurts my head. Second times the derivative of the first plus first times the derivative of the second. Okay. And now we need a calculator. Lourdes, what did you get when you typed in dy dx evaluated when x is 1? And is it 1 degree or 1 radian? What is it? 1 radian. So cosine of 1 minus sine of 1. What decimal did you get? Negative .301. Remember how many decimals? 3. Why? 'Cause. Just 'cause. Okay. I need a coordinate to write. I have a slope now. How do I get a coordinate? What's the x value where I want the coordinate? 1. Where do I get the coordinate from? What's the original function? X cosine. Okay, so the coordinate, the point is 1 cosine 1. Okay, cosine of what? 0.540. Complete with that third decimal. Okay, so the tangent line, y minus the y value equals slope times x minus the x value. Was it preguntas? That's what it looks like. Like it works. Like a little question on stuff? No? Okay. Then I will bring up the homework and you guys can start. There's also textbooks in the back. And the homework is day 16. Have at it.